We are still talking about solving quadratic functions and quadratic equations. So we spent the whole last chapter talking about factoring. We looked at graphing and solving by graphing, which is accurate but very cumbersome. And if it's not an integer, then it gets kind of messy. So let's take a look at another method that we can use to solve a quadratic. It's called completing the square. So to solve an equation by taking the square root of each side, one side should be a perfect square. We've looked at this when we were factoring, that we can find the square root of both sides of the equation, but one of the sides needs to be a perfect square for that to be able to work. And we're typically looking at the side that has the variable in it. We can create a perfect square trinomial where one is not by completing the square. So if I have a quadratic and I'd like to try to take the square root of each side, I can create a perfect square trinomial, otherwise known as completing the square. So how do we do that? To complete the square for any quadratic expression, 1x squared plus bx, notice that my a in front of the ax squared is a 1. We're going to find 1/2 of b and square it, and then we're going to add those results to my 1x squared plus bx. So we're really figuring out what that c is to make this a perfect square. So we're going to practice this, find the value of c that makes the expression a perfect square trinomial. So I have x squared plus 14x plus c, and I want to figure out what should I add to this trinomial to make it a perfect square trinomial. So to do that, I'm going to take my b. So first of all, I want you to notice that a is a 1. So we really want to make sure that a is a 1 because we want that to be a perfect square, and we want to be able to do this in just a couple steps. So a is a 1. We're going to take b. We're going to find half of that. So half of b in this case is 7. We're going to square the 7, and we get 49. So c in this case has to be 49. So I'm going to add 49 to this expression and get x squared plus 14x plus 49, which means that it's a perfect square trinomial. Its square root is x plus 7. So this boils down to x plus 7 squared. So this is what we're trying to create here, a perfect square trinomial. Let's look at another expression, x squared minus 3x plus c. So again, notice that my a is a 1. I want to find half of b. In this case, half of negative 3 is negative 3 over 2. I'm going to square that. I do get a fraction. It's 9 over 4. So my c is 9 over 4. And that was the question, what's c? So c in this case is 9 over 4. So what does that mean? That means if I have the expression x squared minus 3 plus 9/4, that the square root of that would be x minus 3 over 2. So if I looked at how this looks if I go to square this, I am looking for that when I double this, when I multiply it by itself and then double it, I come up with that middle term. So I'd end up with x squared times the square root. I'd end up with x times the square root of 9/4, which is 3/2. And 3/2 times itself, 3 times 2, 3 over 2 times 2 gives me my 3, my middle term there. So I end up with x minus 3/2 is my square root of this perfect square trinomial. So let's actually put this into play. How does that actually help me solve an equation? All right, so to solve an equation by completing the square, first I'm going to set the equation equal to 0. So we want to kind of make sure that all of our stuff is on one side. We're going to make sure that a is equal to 1. So I want to get my a equal to 1. We want to find c to make the expression a perfect square trinomial. So we're looking at what is going to be that third term in the trinomial to get this to be a perfect square trinomial. We're going to add that to both sides to make a perfect square trinomial, and then find the square root of each side. Once we've got a perfect square trinomial, we've done that before in our last chapter. So x squared equals 2x plus 1. So actually I've kind of skipped this equal to 0 step. Now you can do the equal to 0 step. I actually find that kind of helps you see some of the pieces here. But for this you don't actually need to do it. So I'm just going to get the 2x on the side with my x squared so that I have that 1x squared minus bx. So there's my 1x squared minus bx. I'm trying to figure out what's going to go here plus what to make this a perfect square trinomial. So I'm going to take a look at my b, which is negative 2. So negative 2, half of negative 2 is negative 1. And then I'm going to take negative 1 and square it. And negative 1 squared is 1. So c has to be 1 here. So if I want this to be a perfect square trinomial, I have x squared minus 2x plus 1. That's what I want the left side to look like. So to make that happen, I'm going to add 1 to both sides. So I still need to add it to both sides. So here I am adding it to both sides. I end up with x squared minus 2x plus 1 equals 2. From here, we've done this before. I'm going to factor this left side. I get x minus 1 squared equals 2. I'm going to take the square root of both sides. Please remember that we have to find the positive and negative square root of this other side. I have x minus 1 equals the positive and negative square root of 2. I'm going to add 1 to both sides. I get x equals 1 plus or minus the square root of 2. Now from here, we could leave it here, but you may find your directions say round to the nearest tenth. So if I'm going to run to the nearest tenth, run to the nearest hundredth, it's going to ask you for more of a real number. So to do that, I'm going to split it up. 1 plus the square root of 2, and the square root of 2 is not pretty. It's not a nice, neat, perfect square. So I'm going to approximate that. It's approximately 2.4. I'm going to slam that in my calculator and see what I get. Same thing here. So I come up with two solutions. I come up with negative 4/10 and 2 4/10 as my two solutions. Let's try one more. So I have 2x squared plus 16x plus 2 equals 8. Notice I do not have a 1x squared here, so I want to make that a 1x squared by dividing by whatever a is in this case. So I'm going to divide by 2. So I end up with x squared plus 8x plus 1 equals 4. Now from here I want to figure out what should plus c be. Now right now it's plus 1. Now if you want to, you can subtract the 1 and get rid of it, so you have kind of that blank space here to you can kind of picture that there's something missing there. Or you can leave whatever is there, it's just not the right amount. So I'm going to focus on my b here. I have 1x squared, so far so good. I'm going to take my b, which is 8. I'm going to take b, I'm going to find half of b, which is 4. I'm going to square that 4 and get 16, so my c is equal to 16 in this particular trinomial to make it a perfect square. So I want this to be plus 16 here, which means I actually have to add 15 to get that to work. Now if I had gotten rid of the 1, then I would be adding 16, which would work also. So I'm going to add 15 to the left and 15 to the right, and this gives me my perfect square trinomial here, 8x squared plus bx plus c. The square root of the first one times the square root of the second one, that's 4x. Doubled gives me 8x, perfect square trinomial. So factored, this looks like x plus 4 squared. That's still equal to 19. And from here, we've done this before. Find the square root of both sides, positive and negative square root of the other side. X plus 4 equals a positive and negative square root of 19. I'm going to subtract 4 from both sides, and then I'm going to figure out what these are as rational numbers, unless my directions didn't tell me I needed to do that. But for this one, I have negative 8 4/10 and positive 4/10. So completing the square, we're kind of working back to our taking the square root of each side. But I want to figure out what that third term is, that plus c, in order to make this a perfect square trinomial.